Let's begin with question number 2 on this paper. Okay, let's move it to whiteboard, please. Okay, let's read it and start on it, please. Yep. So it says, evaluate this integral. Okay, we need to evaluate this integral. So let's begin. So this means it's a square root. Okay, something like that. So we need to evaluate the integral from 0 to 1 of this particular square root of 3x plus 1, like that, and then dx. So the idea is to rewrite it first in this form, 0 to 1. So you have to write in the exponent power form, because only then we can use the theorems that are available. So dx, like that. Okay, the trick is to realize that, or to do two things. Because when we differentiate an expression inside the bracket is linear means chain rule, we're actually using the chain rule in reverse. Chain rule in reverse. So let's do it first. So what we need to do here is when you integrate, let's put a bit of this box thingy. So integral limits of 1 and 0. So inside the box, what happens? The 3x plus 1 part remains the same. The power part, you just add 1. Okay, this one is just plus 1. And then whatever you add in here, you got to divide by it, because in the chain rule will multiply the inside, and this the second part actually. Okay, this one you have to divide. The reason is being the power, you plus 1, you divide by it, because normally differentiation, I was thinking in reverse, you multiply in front, so now we divide by it. And then not only that, there's a bit of a trick here, which is when you differentiate inside and then you multiply in the chain rule, right? Multiply in front. So you differentiate inside the constant 3. Now we also divide by that. So this is where students sometimes may get mixed up. Okay, so this is how we use this shortcut straight away like that. Okay, now all that remains is to evaluate this further. Okay, let's do that part, please. So this becomes 3x plus 1. Okay, sometimes it's easier to write in decimals, this kind of thing, 1.5, let's say. Okay, and then this becomes, 4, okay, 4.5, right? 1.5 times 3, you can just put in the calculator. So to make it more accurate. Okay, then we have this integral limits of 0 to 1. So that means this is a definite integral. Okay, let's evaluate this definite integral, please. So that means now we're going to substitute. So 3 times, I'll just show the substitution in a little bit of detail. Power of 1.5 like that over 4.5. They need to minus the other one. So substitution always from the upper minus the lower. As we substitute in those values like that, meaning that the 1, the pink value, the 1 is up here, the 0 is here. So just the final evaluation needed for this question. So this will be something like 4 to the power of 1.5 over 4.5 minus, this one becomes 1, 1 to the power of 1.5 over 4.5, which we can further reduce it to, okay, this is just, say, okay, let's put in the calculator straight. Okay, you can put something like this, 4 to the power of 1.5 minus 1, because it's just minus 1, divided by 4.5. I don't take risks. Just put in the calculator, and we should get the answer as, okay, let's do it now, please. So 4 to the power of 1.5 minus 1 like that, then divide by 4.5. That was 7. So 7 over 4.5. In case you want to do another step, this is 7 over 4.5, which will be 14 over 9, or you can write it either way as an improper fraction or as a mixed number or decimal, which is 15 over 9. I would prefer an improper fraction or a mixed number because it's more accurate. In the decimal, we are rounding. Okay, so that's the answer. Thank you.